Welcome to this explainer. If you've been working in the big data space at any point over the last 2 decades, you absolutely know that managing massive datasets used to be, well, a total nightmare. It wasn't just a headache, it was this crazy labyrinth of complex infrastructure, rigid architectures, and, let's be real, those dreaded 3 a.m. pager alerts when a batch job failed. But thankfully, that era is pretty much over. Today, we're unpacking a massive paradigm shift. We're going to look at the death of the very system that started the big data revolution and the rise of the unified pipeline model that replaced it. We're diving into Google Cloud Dataflow, which is the technology that completely abstracted away the infrastructure and totally rewrote the rules for how we extract, transform, and load data at scale.
Okay, so let's just jump right in with this quote because it is a bit of a bombshell. Imagine inventing the undisputed king of big data, the literal blueprint that sparked Hadoop and the entire parallel processing revolution, only to just completely walk away from it. But that is exactly what happened. At the JAX London conference, Martin Gorner officially declared that MapReduce was obsolete internally at Google. He literally said, no one at Google uses MapReduce anymore. For years, if you were doing big data, you were doing MapReduce. That was just the rule. But the stark reality is that the creators themselves had to move on. They realized the very model they invented had some fundamental limitations when it came to the speed and the flexibility that the modern web demands. So they retired it.
Now, this massive shift didn't just happen overnight. Let's trace how this actually played out. It all started back in 2004 with that original MapReduce paper. That paper completely shifted the entire tech industry. But if you jump forward exactly a decade to 2014, Google announces Cloud Dataflow, which was a huge signal that they were taking things in a radically new direction. By 2015, Dataflow hit open beta so the public could finally get their hands on this post-MapReduce architecture. But 2016 is where things get truly fascinating. Instead of keeping this revolutionary tech locked up tight behind closed doors, Google did something wild. They donated the underlying software development kit directly to the Apache Software Foundation. This wasn't just some standard software patch. It was an open-source rebirth that fundamentally changed the trajectory of data engineering for everybody.
So, why the change? Well, the core problem with the MapReduce era was what you might call the infrastructure double tax. You basically had to build and maintain two completely separate systems. You had one model for batch processing, collecting massive amounts of historical data and crunching it overnight. But if you wanted real-time streaming data, you had to stand up a totally different architecture. It was clunky, it was super expensive, and honestly, a nightmare to maintain. The Dataflow era, which was actually built on internal Google systems called Flume and Millwheel, introduced a unified programming model. This is the game changer. Whether you're dealing with a static batch of yesterday's logs or a continuous real-time stream of live user interactions right this second, you use the exact same code. It completely eliminates the need to run parallel infrastructures.
The thing to understand is that Cloud Dataflow isn't just a shiny new replacement for MapReduce. It fundamentally removes the infrastructure headache altogether. Because it's fully managed and serverless, you aren't sitting there provisioning virtual machines. Dataflow just automatically spins up the workers you need and then deletes them when the job is done. It scales effortlessly to handle massive parallel processing, and it's super flexible. Great for everything from moving basic data around to running highly advanced real-time analytics. Plus, it's highly observable. The monitoring interfaces give you this incredibly clear visual representation of your pipeline, so if there's a bottleneck, you spot it instantly. You're literally just focusing on the logic, not babysitting the hardware. But the real secret sauce here, the thing that makes developers so happy, it's the freedom from vendor lock-in. Remember when I mentioned Google donated their code in 2016? That established Apache Beam. What this means for you is that you can write your pipeline code once, using Java, Python, or Go, and then you actually get to choose your execution engine. You are not trapped in the Google Cloud ecosystem. If your company decides tomorrow that they want to run that exact same pipeline on Apache Flink or Apache Spark, you can do it without rewriting a single line of code. Dataflow is just Google's highly optimized, fully managed engine, or runner, for those Apache Beam pipelines.
Let's look a bit closer at how it actually performs behind the scenes. Dataflow acts kind of like a hyper-efficient pit crew. In traditional parallel processing, if one virtual machine gets stuck on a particularly complex chunk of data, which we call a straggler, your entire job is just sitting there, delayed, waiting for that one machine to finish its work. Dataflow handles this so elegantly with a feature called dynamic work rebalancing. If it senses that one VM is sweating and overloaded while the others are just sitting idle, it dynamically slices up the remaining work and redistributes it to the idle machines in real time. It auto-scales horizontally and vertically on the fly, just making sure your pipeline finishes as fast and as cost-effectively as physically possible.
Now, when you're processing wildly fluctuating volumes of live streaming data, your absolute biggest nightmares are dropping records or accidentally creating artificial duplicates. But by default, Dataflow provides an exactly once guarantee. Every single record is accounted for, once and only once. Think about it. If you're a financial institution and you're calculating real-time transactions, this level of absolute precision isn't just a nice feature to have, it is a strict, non-negotiable requirement.
So how does this fit into the bigger picture? Try to think of a modern extract transform load, or ETL, workflow using Google's ecosystem, sort of like a city's water infrastructure. First, Cloud Pub Sub acts as the intake valve. It's ingesting these massive streams of raw data from external systems and apps. Then, Dataflow steps in as the water treatment plant. It reads all that raw data, cleans it up, transforms it, and aggregates it on the fly. After that, the pristine treated data gets loaded straight into BigQuery, which is basically your massive, instantly searchable reservoir. And finally, tools like Looker tap right into that reservoir to give you these beautiful, real-time business intelligence dashboards. It's a completely seamless, fully integrated data highway.
And look, this architecture isn't just being used to power some basic internal dashboards. This highly scalable setup is running mission-critical workflows all over the globe. We're talking about massive ETL pipelines that are preparing data for giant enterprise data warehouses. People are streaming data directly into Vertex AI for real-time machine learning analysis. It's successfully processing the absolute chaos of millions of smart meters reporting IoT sensor data every single second. It's even allowing cybersecurity teams to analyze continuous log data so they can detect anomalies the exact millisecond they occur.
Okay, I want to take a quick pivot here, because this whole pipeline philosophy doesn't actually stop at numbers and analytics. Google has this whole other ecosystem called Google Flow that takes the exact same concept, orchestrating complex inputs and outputs, and applies it to a totally different realm: human creativity. Instead of routing server log data to a warehouse, Google Flow orchestrates streams of video, images, and text prompts. It essentially allows creatives to build customized workflows out of these really advanced generative AI models.
Using cutting-edge tools in this ecosystem, creators are basically building ETL pipelines, but for art. For instance, Gemini Omni boasts incredible multimodality, which means you can feed it text, images, or even audio, and it'll generate or edit video based entirely on your conversational inputs. Then you have tools like NanoBanana, which focuses purely on image generation. And it solves some massive headaches in the AI art space by offering really precise editing control and perfect text rendering. The way they get the strict subject consistency is literally by applying the rigorous structured logic of a data pipeline directly to generative AI. It's completely fascinating.
So, whether you are pushing terabytes of analytical data to train a massive machine learning model, or you're generating these wild, complex video workflows using multimodal AI, one thing is just abundantly clear right now: the old paradigm is dead. The rigid, heavy infrastructure days of MapReduce are totally gone. We're living in an era now where data and even creativity move as a continuous, unified stream. The barriers to entry have pretty much vanished, and the capabilities have completely skyrocketed. So the only real question left to ask yourself is, how are you going to embrace the flow in your next big project? Thanks so much for joining me on this explainer, and I'll catch you in the next one.